Okay, let us get the show on the road. So what I'm going to do today is we're going to basically just draw trig graphs. So you're going to need a ruler nearby and a pen and etc. And we're going to be drawing, but you're also going to need your calculator. And so before we start drawing the graphs, I just want to ask, I need to make sure that you know what the basic characteristics of these graphs are. So I want to know what the period of the sine graph is, if it's just a normal sine graph, the amplitude and the range. I want to know the same thing for cos graph, A, B, C, D, E, F, H, I. Well, A, B, C, H, I. No, wait. G, H, I. I want to know in the chat, give me answers for those 9 things. Now, we covered them a bit in the last lesson, but I'm going to refer back to them in today's lesson. And so we just need to make sure we start with getting clear that we have those, those ideas. So you can come online and tell me, or you can write them in the chat. But what is the basic period of the sine graph? That's question 1. What's that going to be? How long does it take for a full cycle to be completed with the sine graph?
Let us know what you think, guys.
These are like the building blocks. Without these, the calculator magic will do you no favors. Then once you have a bit of like stuff with you, then the calculator can make life a bit easier. So that's what I'm looking for. 360 for the sine graph. And now I want to know what is the amplitude and the range. And even if you get it wrong, I don't mind. It's just about a matter of putting in that. Okay, give me a thumbs up if you're out there and you can hear me. Hey, welcome Muji and Kinas and William, Owami, Teddy, Lesejo. Welcome to all you, ladies and gentlemen. We are just trying to write in these values that are going to help us understand how to draw these graphs in the lesson. And so far, I've said that the period of the sine graph is 360. And the amplitude is going to be 1. And the range is going to be between -1 and 1. So that is for the sine graph. Now, one that I want to know is I want to know for D, E, and F, what are the correct values for those things? Because these characteristics are going to help us draw these graphs. Welcome, Zanele. Yeah, Teddy. Let's go to you. Hey, Teddy.
Afternoon. The period of cos graph will be 360.
Perfect.
The amplitude will be 1 also, and then the range will be -1, 1, 2.
Yep. So it's kind of like sine and cos are long lost cousins. They're quite similar in a lot of ways, huh? And Teddy, do you know anything about the tan graph?
The tan graph period will be 180.
Yeah.
And then its amplitude will be, it doesn't have actually amplitude.
Well done. Well done. Yes. It's a bit trickier, huh?
Yeah.
So I'll help you out. So this is going to be it's just going to be minus infinity to positive infinity. That's a bit of a sneaky one. But basically it goes, the range, it goes up forever and down forever. So you'll see what I mean when we draw the graph, but that was fantastic, Teddy. Thank you so much. So let us go to the arena of drawing graphs. How do we draw graphs? So I'm going to give you an example of how we draw graphs. And I'm going to start with a very simple example. So I want to draw the graph of y equals sine x on the domain. This is 0 to 360. So the 0 to 360 domain is over here. Now, I have a pre-written up number line, but I could also draw it myself if I need to. But for today, it's fine. Now, I happen to know that we said that the range of the sine graph was 1 to -1. So let's put in those values over there. And we're going to notice these are 30, 60, 90. Okay. So I could draw the graph from memory. And one of the things that we know about the sine graph is we know that the default period is 360. But when we draw a graph, we use what's called the step size. And so in order to get the step size for the sine graph, we take the period of the graph and we divide it by 4, and we get 90. So what's going to happen with the sine graph is we're going to draw it in little sections of 90 degrees. Now, if you learn this off by heart, you can start here and know the shape of the graph and know that for the first 90, it goes all the way up to 1. And that's not the most perfect curvy graph in the world, but that's the first step. And then the second step is just going to be like that. Now, that isn't a full cycle, 0 to 360. We've still got another 180 to go. So then we would go like this, down to 270, and then up to here, up to 360. And that's what you can do if you're just doing it out of your head. But if you want to check, or if the graph is getting harder, you can use your calculator to help you. So how do we do this? We click mode. And once we've clicked mode, we click table. And then suddenly we get this thing f of x. And because the function I want to draw now is y equals sine x, I'm just going to click sine. Then what I do is I hit alpha, which is kind of gives me access to the red keys, and x, and I close my bracket. Now, I think it would be good if you played along with me if you can. So just give me a thumbs up if you followed what I've done so far. Give me a thumbs up if you followed what I've done so far. Okay. Now, the next step is to hit equals. And I have a second function turned on, but in this case, I'm only interested in one. So I'm going to leave it out. And I hit equals and I go, where do I start? Well, in this drawing, I start at 0. That was the domain. So I go equals. And where do I end? I end at 360. And that was for this particular question. Then we have this thing called the step size. And that's what I was talking about earlier with this working out the 90 degrees. Because the period of the graph is 360, and for the sine graph, we have 4 sections, the step size that we're going to put in is going to be 90. And if I hit equals, what we notice is we get a table where various points that are helpful to me are given to me. So let's just see how I could use this. So the first point is 0, 0. Well, good news is my graph goes through 0, 0. The second point is 91, which is here. The third point is 180, 0. So that's good news for me. Then I hit the down arrow and I get 270s at -1. So that's good news for me. And then 360s at 0. And so actually the calculator can tell me if my points are in the right place. And so then the last thing I normally do for my graph, often in exams, they ask you to label the turning points. In this case, that they're actually labeled, they're on a grid line, but sometimes you have to do this idea where you have to label the points, but I'm not going to stress too much about that today. And then we also label our graph. This simple idea of knowing about step size and using your calculator can make it much easier to draw trig graphs. And so I want to just get a feel for the class. Do you understand? Because we're going to do an example now with you guys. Do you understand how to do it using your calculator like that? Give me a thumbs up if you do, or ask a question if you'd like me to go over a different part of this question. Okay. Anybody else have a question or comment before we move on? Okay, well, let's introduce a little bit of a change to my graph. So I am going to come along now and I'm going to make some changes. And I'm going to say, I want to draw the graph of y equals 2 sine x over the domain 0 to 360. And I'm going to give those of you who have kind of feel like you've mastered this a chance to go ahead and try and do it and draw it on a Cartesian or on a graph like this. If you want, if you don't have graph paper nearby, just draw yourself your own one like this. Just go straight line and then across, and then just make little markings that you can use on your page. So I want you to try and draw the graph 2 sine x. I haven't even told you what sort of change that is, but because your calculator is your friend, so what I'm going to do is I'm going to hit mode, and then I'm going to hit table, and then the equation I'm going to put in this time is going to be 2 sine, and then I hit alpha x, and that's how I start the process, but I want to leave the rest to you. And then once you're done drawing your graph, I want you to put done in the chat, and then we'll talk about how we can do it.
Mr. Ace?
Yeah.
Lisaho says they missed the first one that you did.
Okay. It's fine. I'm going to go through this in huge detail now. I just want to give everyone a chance to have a go and think about, do they know what this graph will look like? And then I'll explain it in absolute detail. So as we wait for everyone to give the trig graphs a go, don't be afraid to, if you want to have a chat or just ask a question about my method, you're welcome to go ahead and do that. I'm going to continue with my calculator now, and I'm going to go equals. I'm ignoring the g of x. Some of you won't have this on your calculator. That's fine. Then where do I start? I start at 0. Where do I end? I end at 360. Because that's what the question asked. And what is my step size? It's 90. And what I notice is there's some differences in my table, and that's what I want you to take a moment to do. So the first point is exactly the same. And you might be able to draw this whole graph without your calculator, but not a bad idea to maybe think about what points does this have to go through. So I've done the first 2, in fact, I've done the first 3 points for you. And then once you're done with that, just say done in the chat or ask a question. Try and get some water. Okay, so who can tell us in the chat, how do I get the other points? Pretend I've forgotten, and now I really want to see, I know there's more points on my calculator. How do I, what key do I need to press? Pretend I have a case of spontaneous amnesia. So I've recovered my memory, and it turns out it is a downward arrow. So the next point is going to be 270 minus 2. So let's see if I can find that. 270 minus 2. And the last point is 360, 0. And so if I want to draw this graph, all I need to do is make sure I have the right shape, and I connect my points up like that. And this is the graph of y equals 2 sine x. Now, what I want to know from you, the students, is what has changed in this graph compared to earlier in the lesson? What has this 2 in front done?
Any ideas or hints, guys?
How would you describe, in fact, we can even look at the previous graph a little bit, maybe, if I just zoom in a bit. There we go. There are the two graphs. What is different between them? That's what I want to know. Or are they the same? Yeah. So William has said the range has changed. Exactly. So the range is now between 2 and minus 2. And we also say the amplitude has changed. So the amplitude is how high it goes from the position of rest up or down. Another way of finding the amplitude is to say what is the maximum value minus the minimum value divided by 2. So in this scenario, the biggest value is 2. Let me just... So 2 minus 2 over 2, which is just 4 over 2, which is 2. And it's a bit of a mouthful, isn't it? But that's helpful in more complicated graphs. And so what we call this is, we call this an amplitude change, but the method still works. Okay. Are there any questions or comments about this graph? Otherwise, I'm going to move on to the next graph. And this, you're going to fly more solo on this one. Okay. Then I want you to draw for me the graph of y equals 2 cos x on the range, oh, sorry, on the domain 0 to 360. So over to you guys, and I'm not going to say much. All I want is a done in the chat when you are done. But if you are unsure, let me, ask your questions. I'll gladly debate or discuss something you're unsure of. Ah. Okay. Let me actually start this again. Hold on. 2 cos x. So that's 0. So let me know in the chat when you're done drawing your graph. (118 minus 2). That's up there. So I am liking my friend the calculator. It is definitely making my life a little easier. And so, yeah, we've managed to change, do these graphs pretty well so far. So are there any questions or comments? I want to, yeah, otherwise I'm going to squeeze in one more here. Okay. Well, let me, maybe I went a bit quick there. Let's see if I can bring that up. Let's leave both on the screen. Okay, so your next graph that you are going to draw for me is you are going to draw for me the graph of y equals tan x on the domain 0 to 360. Now, there are some changes with the tan graph. And before we start, I want to ask the class, can you maybe help me in remembering what are some of the key values that are different with the tan graph?
Mr. S, we have a hand from Teddy.
You can unmute Teddy. Yeah.
Sir,
It's different, Teddy.
by the calculator, sir. The start is always gonna be 0 and the end will always be 360.
Okay. Exactly. So at the beginning and end are going to be 0 and 360. But what else is different? Is there anything that's different about tan?
Yeah.
So remember in the earlier questions, I asked you, what is the period of the graph? What do you think the period of the tan graph is?
180, sir.
Yes, exactly. Now, there's also something else that's different. The step size is different because when we draw the tan graph, we don't draw it in 4 sections. How many times do we, well, how many sections do we use for the tan graph?
4, sir. 45.
Okay, you don't actually use, so for the tan graph, what we do to get the step size is we divide the period by 2 and not by 4. And so my step size is going to be 90. It's going to be a little bit different because the cos graph we draw in 4 sections, the sine graph we draw in 4, the tan graph we almost lift our pen twice to draw it. And so that's why we divide it by 2. Thanks, Teddy. That was great. Now see if you can draw the tan graph.
Okay, sir.
So what am I doing here? Okay, let's start again. Road. Ah, now there's something funny going on in my table, or maybe it's not so funny. It says there's an error at 90. Can anyone help me understand what's going on there? Maybe you've learned something in class about this. What is that 90 with the error? What's that about? Have I lost my marbles? Has my calculator lost its marbles? Which is a saying for they're going crazy. What's going on with the 90s there?
Would anyone like to tell us?
I mean, normally when they say error, that's a bad thing. So I'm getting a bit worried here, but maybe not so worried. Muji, I will explain the steps again now. Yeah, absolutely. So, okay, let's go through this again. So I go mode. Okay, I'm already in table mode, but if you weren't, you go mode 3 for table, and now you get your function. I'm trying to draw the tan graph. So I click on tan, all right? And then I hit alpha, which is like the red key, and X to get the X variable as an input. Close my bracket, and now I'm ready to roll. So I go equals. I'm going to ignore g of x for now. It's not always turned on everyone's calculator. Go equals again. Where do I start? I start at 0, equals. I end at 360, equals. The step size is 90. And so that's why I went through so much trouble with Teddy to kind of talk about that, because it's important that you know that the step size calculation for the tan graph is different. Okay, now I've got this error thing. Now, what this error thing means, it's not an error. It just means that your graph can't go there. So it's actually what's called an asymptote. And so what we do is on the tan graph, we just draw a dotted line upwards and downwards to show basically the graph can't go across there. Now, my other points are going to be at 0, 0, which is here, and then at 180, 0. And then there is another thing, 270 is another error. So that's going to be what's called an asymptote. And then the last bit is 360. Now, what that might be doing for some of you is you might be saying, okay, great. How do I know actually how to draw this? Now, at this stage, what I would say is that you should know the shape of the tan graph, but if you need more points along the way, we can go back in and change the step size. So we could make the step size 45 if we wanted to. But essentially, if you know the shape of the tan graph, it goes like that. And then on this side, it goes like that. And on this side, it looks like that. So that would be y equals tan x. However, I can see some of you saying, okay, but how do I know the shape? I would like some more points. And so we actually can go back. So let's go back for a second. We go to tan x and we go to 0, n360, and instead of a step size of 90, we change it to 45. Now, what's going to happen if I do this is my table gets a lot fuller, but I do get extra information. So then, if we look at this thing here, at 45, the graph should be 1, is what this is saying. So that's that point over there. At 90, it's an error, which is fine. At 135, it's at -1. Okay, I haven't drawn my graph perfectly to scale. It should actually be, but basically it's going to be a point on this side. And so we can go on and get the extra points. However, if you kind of get to know the tan graph, you kind of know the shape of the graph generally, but you can use your table to help you if you need to. All right. Can I get a thumbs up if people are feeling like they understand the basic idea of how to draw the tan graph? A thumbs down if you're feeling very confused. Just want to get a feel for the room, and then we're going to take a break. Okay, because on the flip side, we're going to start playing with some of these graphs and changing them around. Oh, love it. Okay. Now, you know what it's time for? it's just gone past half past. So what we need to do is we need to stretch it out. So I want everyone to turn on their cameras and join me in a glorious stretch. And your body and my body, maybe my body even more than yours, needs a good stretch.
Guys, please join us in the stretch.
I'm clicking a lot.
We have William joining us today.
Come on, William.
Also. Please put on your cameras. Let's see your lovely faces.
Want to say hello to the people.
Don't be shy. Shout out to Bonalo.
Oh, the stretch is so good. Okay, I'm going to do a little squat.
Come on, guys, give your mind a break. Yes, Rosaria. Shout out to Rosaria.
There we go. And roll those shoulders. The shoulder roll is such a lovely feeling. Oh, and stretch your neck out. Oh, there we go. I can feel the circulation returning to my body. I hope
the brain just got 10 times faster.
I'm like, wow. It still surprises me how much better I feel after I've stood up for a little bit. Like my concentration gets reset. Completely. Okay, let's have a brain break. So here is today's question. What numbers do you get when you multiply all of the numbers on a telephone number pad? Who thinks they know? Look at that. Oh, you guys are too smart. So if you remember the telephone number pad, there is indeed a 0 on the telephone number pad. And if you multiply whatever you want, so if you started off doing this, you're not wrong. But what's really, really important is at the end, it's something times 0. And so anything multiplied by 0 is a good old-fashioned 0. So well done to William and to Rosaria. You spotted that lightning quick. I didn't give a chance to even get you to multiply anything yet.
Well done, guys. I didn't get it, so well done.
Lebo is always my guinea pig for my brain breaks, but I say to her, look, it's not fair because there's only one of you, whereas there's lots of students.
I'm always so bad at them.
Okay, let's return to trig graph land. So let's change it up a little bit. Maybe let us do an example of a different type of graph. So let's go and do sine 2x. Now that is a shift, or it's a different, not a shift actually, it's something else. But what does this 2 do to the graph? Does anybody know? Because I'm going to try and draw the graph of sine 2x now on the domain 0 to 360. And I want to know, there we go. Can we unmute Teddy?
So it affects the period of the graph.
Perfect. So can you tell me how it affects the period?
Since now we have sine 2x, the period now will be 180.
Yeah, so we divide by the number, whatever that number is. So the period is going to be 180. What is my step size going to be?
Isn't it going to be 45?
Yep, you're on form. Well done. So your step size is 45. And so what I want is I want to give you some time now that Teddy has helped us with the basic information. Now, because the number in front isn't given, it's automatically a 1. So the amplitude in this question is going to be 1. Now, I want you to use your calculator or use whatever you like and try and draw this graph. And when you finish drawing it, I want you to say done in the chat. Let me go back and do this. Mode. Oh, don't have to do that, but sine 2 x the step size is 45. So, okay, my 45 is going to be here. So let's make it 1. So I start off here, and then at 45, I get to 1, and then here I get to there. Okay, so let me know when you've had a crack at doing this. Then I'll make some more comments. Now, let's that would be. And so I haven't labeled the turning points, but that is the graph that I seem to be getting. If you got the same one as me, just give a thumbs up in the chat. So what I'm noticing is that we get a whole sine graph up to here, and then we get a whole nother sine graph in the next 180. And so we say the period has shifted to 180 degrees, and sort of it's almost like it's horizontally been compressed a bit. If you look at how we fit a whole up and down cycle into 180 instead of 360 as before. So that is one type of change. It's called the period change. And all we need to remember for future reference is we divide the normal period by whatever the number is in front. And then the way we find our step size was just divided by 4 like last time. Okay, now I want to change something now. I want to change the number in front from a 1. Ooh. So I'm changing this. Well, let me record again here. I'm going to say, draw me the graph of that trig graph. So 2 sine 2x. I'm going to draw it on the same set of axes. And I just want to know, draw me the graph of 2 sine 2x. See if you can do that. And it's going to be on the domain 0 to 360. How will that change things? Maybe our calculator can help us. I'll put a 2 in there. So a key insight is that the period is still 180 of this graph. The only thing that's changed is the number in front. And so ask yourself, what does that number in front actually do? And whatever it does in addition to whatever was done before. When you finish, just put done in the chat. Let's see what the calculator says here. The calculator says 0, 0 is fine. Then 45, I'm at 2. And then at 90, I'm back at 0. Put a 2 there. Oh, I think I know what's going on here. I think that's going to be there. That's going to be there. Oh, no, I can do better than that. So what I'm seeing is that the graph is not only horizontally compressed or the period is changed, it's also stretched upwards by a factor of 2. So it's almost like we squished it horizontally and then we stretched it vertically. And so there are 2 transformations that have happened with this question. Are there any questions from the class, or are you following what's being done? Maybe just give a thumbs up if you feel good. I'm only going to ask you one more question and then we are going to wrap it up for today. Oh, good. Glad to see that, Muji. So what is the last question going to be for the day? It's actually going to be quite simple. I just haven't covered it yet so far today. If I can select this, let's have a look here. Ooh, I'm doing something a bit odd there. Okay, so what happens to a trig graph if I say I have the cos of x plus 1? I want you to draw that graph on the domain 0 to 360. And if you can put it in the chat, what do you think happens when I notice how I've closed the angle part that relates to the trig function? That's all locked away, and it's an additional plus 1. So I want you to draw the graph for me. And I also want you to tell me what is that plus 1 doing to everything. Let me say cos x.
Anyone who would like to come online and tell us?
Reveal the insight that you have. I am liking, my friend, the calculator level. What do you think of the calculator? Does it irritate you, or is it useful to you?
Loving the calculator.
Okay. No, good. And my students at home enjoying the new character on the scene. I must be honest, I am liking it. It does move the graph up and down. Yes, it's a vertical shift. Hopefully the calculator tells us the same thing, but I think it's a vertical shift.
Awesome, Owami.
And then, okay, my step size is not going to be 45 because the period of this graph hasn't changed. So what is my step size going to be? Well, normally it's 360 divided by 4. So my step size is 90 for this graph. So I'll put 90. So we're trying to draw the graph of cos x plus 1. So 0, 2. Oh, interesting. Then 91, 180, 0. 271. Oh, that's a bit sneaky. 271. And then it's going to be 362, which is up here. So this is what I do like, because what I realize is that the +1 has just moved the whole graph up by 1. So normally the cos graph is between here and here. But now, because of the +1, everything is moved between here and here. We say the range is no longer between -1 and 1, it's between 0 and 2. And so what we should get now is a graph that looks something like that. And that is the graph of cos x plus 1. Okay, are there any questions or comments from the students of the room? That was a little bit trickier, but as long as you had that skill with your calculator should have been giving you some clues there.